Now we have to discuss about 5.2. We have to know two things. One is vaporization. Vaporization is when liquid changes to gas. When molecules get enough kinetic energy, the gas molecules escape from the attraction and becomes gas. So this is vaporization. For second one is condensation. Condensation is when gas change to liquid. So when molecules have low kinetic energy, the gas molecules have attraction with each other and becomes liquid. This is condensation. So we have to know about dynamic equilibrium. At dynamic equilibrium, we have to know the vapor pressure is always constant at a temperature. At first, the rate of vaporization is higher than the rate of condensation, but eventually, the rate of vaporization will equals to the rate of condensation, and this is called dynamic equilibrium. But there is a requirement to achieve dynamic equilibrium. First, it happens only in closed system, because when the system is closed, there is no vapor molecules escapes from the system. For second requirement is the temperature must constant, and third requirement is the vapor pressure must constant. So what is vapor pressure? Vapor pressure is the pressure exerted by vapor in equilibrium with its liquid in a closed container. And we have two systems. One is open system and another one is closed system. So for open system, actually it's very easy one. It's a system that vapor molecules will diffuse away when gas evaporates. Evaporates means liquid change to gas lah. So for closest system, dia terbalik saja, is a system that vapor molecules cannot escape when gas evaporates.
Vapor pressure happens in closed system when vapor molecules cannot escape from the system. First, they remain in the container. Second, in contact with surface liquid at constant random motion. Lastly, continually strike. The pressure exerted is called vapor pressure. Vapor pressure, when more volatile liquid, it will exert a greater equilibrium vapor pressure than less volatile liquid at same temperature. Second, for volatile liquid, attractive force between molecules are weaker compared to non-volatile liquid. Last but not least, when less volatile liquid, it must absorb more energy at higher temperature to vaporize and its vapor pressure to reach atmospheric pressure. Thereby, it boils at a higher boiling point. The relationship between vapor pressure with temperature, when temperature increase, average kinetic energy molecules increase, thus overcome the attractive force between liquid molecules. Rate of evaporation increase, vapor pressure increase. So conclusion is temperature will increase when vapor pressure increase. Besides, relationship between vapor pressure with intermolecular force. When intermolecular force weak, liquid molecules easily escape to form vapor. Thus, liquid with weak intermolecular attraction are more volatile and higher rate of evaporation and produce high vapor pressure. So we can assume that intermolecular force decrease, vapor pressure increase.
Boiling point is the temperature where the vapor pressure of a liquid equals the external pressure. In other words, the normal boiling point is defined when the external pressure is 1 atm. As we can see, for water, the boiling point changes at different altitudes. For example, lower on Mount Everest and higher at the Dead Sea, because the external pressure is different. Boiling point is the process where liquid changes to gas at both the surface and inside, and it always happens at a specific temperature and pressure. During this process, the temperature stays constant even if heat is supplied, and we can see bubbles forming inside, rising to the surface, and escaping when the vapor pressure equals the atmospheric pressure.
So, what is the relationship between intermolecular forces, vapor pressure, and boiling point? First of all, if IMF are weak, the liquid molecules easily escape to form vapor. Therefore, the liquid vapor pressure is high. Then, the boiling point of the liquid is low due to the less energy needed for its vapor to achieve atmospheric pressure. So, for the exercise 4, the question asks us to arrange this liquid in order of decreasing vapor pressure. So, it will be methanol, ethanol, propanol, and butanol. This is because as the carbon from the methanol to butanol, the intermolecular forces, especially hydrogen bond and van der Waals forces, become stronger. This leads to a higher boiling point and lower vapor pressure. Therefore, vapor pressure decrease in the same order as increasing boiling point. For question 5, it asks us to determine whether propanol or propanol has a higher vapor pressure at room temperature. So the answer is propanol has higher vapor pressure than propanol. This is because propanol can form stronger hydrogen bonds due to the presence of OH group, which significantly increases its boiling point and reduces its vapor pressure. Propanol with only dipole-dipole interaction has weaker intermolecular forces, making it more volatile, which is easier to vaporize. So it has higher vapor pressure at room temperature.
Quack, quack, quack.